All right, so welcome everybody to our session on providing access to non-SaaS components of Modern GIS. I'm Jerry Miller, sector lead for the education team, and co-organizer for this workshop is Peter Knoop at the University of Michigan. I believe many of you were in the prior sessions, and Peter and I have been running these workshops for a number of years now at Summit, and of course they always keep changing. So this one is a sort of relatively new one, a new addition that is to some of the traditional sessions we've done. And Peter, would you like to just join for a second on camera and introduce yourself?
Yeah, hi, I'm Peter Knoop at the University of Michigan. I'm a research computing consultant there in our College of Literature, Science, and the Arts. And yeah.
Wonderful, thank you. I know for those of you who are in the previous session, it was a bit of a marathon, but we keep going with these wonderful, exciting topics. And for this session, we'll have two other panelists join us. So Ryan Danzy, who is from the performance engineering team at Esri, who's going to talk to us a little bit of the kind of the will present a broad overview of the virtualization options at Esri, as well as Miriam Olivares, who is a GIS librarian at Yale University. And they have a wonderful story that they're going to share with on-premise virtualization and how things got improved for them. So what we'll do, so as I mentioned earlier, this is one of these, one of the series of sessions on managing ArcGIS in higher education. We'll define in a second what non-SaaS means, but really the focus of this session is, so say we're supporting students, faculty, staff who are running ArcGIS Pro in particular, and most often on Mac machines or their own individual devices, or we're virtualizing ArcGIS sort of across the whole institution. So we'll take a look at different options of how this is done. And we've been having some of these discussions for a while now, but how this particular session was born is, it was a few weeks ago, there was a meeting with a number of geospatial librarians, probably about 12 folks in the room or so, and we're discussing various challenges and things that we're working on, challenges that we have, and having issues with Mac machines or supporting students, faculty, staff that come with Mac machines was one of the kind of the key things that came out of it. So therefore, we wanted to put the session together and continue some of those discussions. So first, to sort of define what non-SaaS is. So SaaS being ArcGIS Online, software as a service, all the apps. So non-SaaS is the desktop apps that are out there. ArcGIS Pro, CityEngine, ArcGIS Insights also runs natively. Particularly, we'll focus the session on ArcGIS Pro. That's what we see most often, as well as ArcGIS Enterprise. So we'll talk a little bit about that. Peter has a little bit of information on how they deploy it, but also it's part of an application that it's not a SaaS application, if you will. So the outline is going to be different options for providing access. We'll talk a little bit of the important notion of moving to SaaS. We'll talk about installing ArcGIS on student, faculty, staff machines, and we do know that Macs could be a challenge, as I mentioned, and we'll take a little deeper dive into virtualization, a couple of different options that we have there. So before we get started with, with the actual non-SaaS components, so there's something to be said about the notion of the opportunity to move to SaaS. So the first thing probably to ask yourself, again, regardless of role, whether student, faculty, staff, or you're supporting student, faculty, staff, can the educational objectives that we have, whether again, it's for research projects, whether it's teaching, can they be fulfilled by a SaaS application like ArcGIS Online and apps instead of Pro? There's a lot of advantages of SaaS technology, as we may know. All students, faculty, staff need is internet connectivity. It's a uniform, standard environment. Things are going to work the same for everyone, and there's so many capabilities that are available as part of ArcGIS Online and apps. So one of the first things to kind of think about is it's never a one-on-one. Well, here's ArcMap. We're going to swap it directly in ArcGIS Pro. We need to kind of rethink what is it that we can do with SaaS technology as part of this modern GIS pattern. You see a couple of quotes there. I'm not going to read them, but that is definitely something to think about from the get-go. So when the minute someone comes in, have a Mac, want to be doing this, maybe do ask that if something can be done with SaaS. And if not, then some cautionary tales, things that we have heard from folks that have come along the way from the community. It's very important to get the virtual environment right, whether it's from Macs or cloud or on-premise virtualization. So for ArcGIS Pro to work at a useful level, That goes hand in hand with the next one. Follow the system requirements from the start. It does save headaches in the long run. It saves time and hassle. So it's important to do that. And very often, folks, we have seen instances where folks look at GPUs, but they disregard graphics resources. So we want to look at all the system requirements. And then one of the more important things that has been a theme of this session, and it's important to emphasize in this particular session as well, is to collaborate with your IT colleagues. And you're going to see that from the panelists and the stories that they share. Very, very important, as they know, obviously, how to deploy other similar systems cross campus. It's not just ArcGIS. So as a recap, in terms of how we provide that access to Mac Windows-based PCs. So first ask is, can we use ArcGIS Online instead? It's a standardized environment, many advantages of it, ease of access and so on. And then if not, obviously, or for other purposes, it could be both, doesn't have to be one or the other. Just in terms of providing that access, particularly to those non-SaaS components, there are a couple of different options. One is to use, we called it an institution managed solution, and there are a couple of different things there. So either obviously campus labs, that's a standardized environment, or we know we don't want to necessarily have to go to campus all the time to do our work, to provide a virtual environment, which could be on-premise. It could be also a cloud environment as well. But the point of it is it's a standardized environment that's supported institution-wide, that everyone can experience the same thing. Again, lots of advantages there. The other option is the bring your own device sort of thing. So everyone, students, faculty, staff, bring their own devices, could be Macs, could be anything else. We do know that Macs require that extra step, but it's a bit more of a varied environment, different kinds of levels of support. So regardless of which option you go, it's important to manage those expectations, and it's going to be different, just to manage the support workload as well. And there's really no one correct choice over the other. The correct choice is one that works for you, that you have the expertise to support and also be able to fund. When we talk about funding, we don't necessarily just mean access of cloud solutions or access of software and such, but we also mean the time of people that takes to provide that kind of a support. So hopefully that makes sense. And typically what we have seen is that a standardized environment, which is institution virtual environment, does provide a little bit more return on investment when all costs, including people's time to support, are accounted. So with that said, I'm going to let our first panelist, Ryan Danzy, performance engineer at Esri, join and share just the broader virtualization options that are available. And then we'll move on to Miriam and Peter afterwards. So Ryan, I'll stop sharing and let you share.
Thanks, Jerry. Thanks for having me here today. So let me share my screen real quick. Get this going. Okay, you should be able to see my screen right now. And this is me. So I'm on the performance engineering team, and I spend a lot of my time looking at ArcGIS Pro, looking at our different software stack as well, from desktop to CityEngine. And I want to make sure that these systems run our software properly. So I've got a lot of knowledge in a lot of different areas, and I apologize. This is going to be fairly brief. It is an overview. If you do have questions, my contact information is listed here. The slides will be shared as well. You can reach out to me directly if you need to later on, but you can also ask the questions during the Q&A if you don't mind. So let's jump into it. What makes ArcGIS Pro different? And I always start off with this because it really is the root of why we have these discussions. ArcMap, wonderful product. However, it's our older product, so it's not getting the same updates. Why though? It's not getting the same updates because the architecture that it's built on is just dated. It's different. Pro is a 64-bit application, which is multi-threaded. This is very different in the way it's performing when you look at desktop and you're talking about a single threaded application. This means that a CPU will get hammered by hits much faster and rapidly and through multiple threads versus just taking one for one operation, send it, bring it back, send it, bring it back. This is the freeway versus driving down the side streets in a residential neighborhood. How do we access from everywhere? Now, this is the big thing that you're here for, and this is the best way to describe it. We want you to be able to access Pro from any type of system. That means on-premise, that means the cloud. And the cloud has a lot of different options. You're going to see more and more especially over the years. And you're going to see more releases from Esri as far as blogs that I'll do related to different different companies that'll start popping up on this list as well. On-premise virtualization typically runs with two names a lot of times. People usually hear the word VMware or Citrix. There's other options out there, but they're the real main players that we focus on with a lot of this content. The big focus on virtualization is always how do we make it work and what is it going to take to make this work? And that's going to involve aspects of hardware. That's going to involve aspects of software. And software, when I say software, I'm not just meaning the Esri software stack. This is going to be the software that's going to make everything run in the background. It could be the VMware hypervisor. This could be the NVIDIA Grid, or it used to be called Grid, vGPU manager. And then in the cloud, all of that's very similar. So this slide is a good representation of the way an infrastructure is created in a very quick and easy manner of understanding. When you compare the two differences of a cloud environment or an on-premise environment, you're going to have certain components that are going to be there in an on-prem environment that you're going to have to maintain. Now, this is going to be your data center, and this is why Jerry is referencing work with your IT providers, collaborate with them, make sure that the system requirements are being followed and looked at. And I know from my end as a former IT system admin, I would put in systems and I know what I've done before and I know this works, or I have hardware that's already in place. This can transition and work for you. You don't know necessarily. That can happen. And the main thing is the system requirements are what they are because it's what is known to make things work. And there can sometimes be some little leeway in there, but almost always the system requirements are not one of those negotiables that will say, this will work, kind of. It's really this works or this doesn't. So be sure to follow that and compare the differences, the cloud versus the on-prem environments. When building out a system, you're looking at the hardware that's going to support it. And this is where I mentioned follow those system requirements. This is kind of an update slide of what is coming very rapidly. And in the next couple of months, you'll probably see blogs. I'll start with the one related to this piece of hardware. This is going to be our new appliance that's going to go out there. Now, this is a collaboration between Dell and NVIDIA and Esri. We work together to try and find the best reference architecture. This architecture is a recipe for success. It's already pre-cooked if you buy it, but it's also, you can look and see, I need eggs, milk, flour, sugar, and I've got cake. This is it. This is the baker's recipe. So you can follow this information to help build you along the way and understand what software or what hardware works with the software. In this, I've got several references here. The VDI architecture from Dell. This is a collaborative piece that we worked with Dell to get this information out there that shows here's how to buy what you need for one of these systems that can support GIS. Additionally, if you're, let's say, a Cisco user, I have a link in there for the NVIDIA page for certified servers. We will be shifting all of this to the new product lines from Dell and NVIDIA. So the R750, whereas in the past we were on the R740 with a prior generation processor. So this is the future. This will be announced probably within the next month or two as we get through testing. We haven't even received our hardware yet, but once we do, it'll be a rapid implementation trying to get that out the door. So as we move into the cloud, there are a lot of options, and you'll hear more information from Peter on this. But the big thing about the cloud is you get so many different choices. What works? If I tell you I've got 9 different options for you from one single provider, but then you look at the list and you see 105, which one works? Not all of these instances in the cloud are always just, oh, I just need one. I'll use the T1 style. No, that doesn't necessarily work. That's for general use. The list that we put out there explains the different generations of the different options. So for instance, EC2 has so many different options, But really, the EC2 with the G4 is the one that we spend the most time talking about. And there's a couple different options, the G4DN and G4AD. But these components start being the same across the different providers as far as what options you have available. And in the last couple of years, we had been telling everybody with the appliance for the on-premise virtualization that the T4 is the go-to card that we have. We really like this card. It does real well for almost all purposes and uses that we've found. So the cloud providers also got into that. The G4 from Amazon has it, but also you have the NCIS, which has the T4 GPU as well. And this started becoming more and more prevalent, partially because of the cost of the card, but it's also a very capable card. And we see the same option in Google. Google even has that same similar platform. And all of these bring the desktop to you. But in addition, there's other options. There is a streaming option that is out there. And it all really depends on what is the most need for the environment. Now, for some classroom scenarios, running an AppStream environment works very well, especially if you want something pre-canned and cooked and just brought forward in a browser, which means you can use a tablet, a Chromebook, a MacBook, in reference just a browser at any given point that has the appropriate access. So that's where that functionality from the cloud really pays off, is that flexibility that you garner from this technology. One of the favorite subjects I run into is the ArcGIS Pro on the MacBooks. Now, virtualization is done several different ways, and I've spoken about virtualization for an on-prem environment. Now, this is enterprise virtualization. There's a difference between enterprise virtualization and then desktop virtualization. You've also heard about the cloud. Now, as we shift into the Mac, we're talking about using a desktop virtual system. And that's very, very similar to the way a server-based or enterprise virtualization works. You are creating a file-based VM, and full disclosure, all VMs are really just files. There's just a series of files that then runs calling hardware information on a server. So in this case, the Mac is the server, and it's going to run typically one VM on the system. It's not going to have multiples, usually just due to limitation of resources. You may be able to have many there, but you probably don't have the full resources to run all of them at once, just because RAM, hard drive space, GPU, CPU, just depends on how much you have based on each hardware piece or hardware platform. So with hardware virtual or the file-based VMs with Parallels or VMware Fusion, and I'll leave Boot Camp alone, that's something for another time, but Parallels and Fusion brought the option with our Intel-based MacBooks. So a MacBook is fantastic when you have it, but if it doesn't have the system requirements met as well, this MacBook won't do anything. But if it meets the system requirements from the CPU, the GPU, and have enough RAM, then it's able to take on this role with Parallels or with Fusion. And this is going to give you the ability to have that VM running and sharing all of those resources inside the system. Normally, I work with Fusion most of the time. We have other people working with Parallels. But the thing I've always liked about Parallels is that when I run it, with Fusion, I'm always able to see the applications that I want. So ArcGIS Pro as part of the dock. So it really does feel native, so long as I'm running the VM. If I turn the VM off, those options are no longer presented. But that's where this ability really works. Again, we've met the system requirements, and then we can use Parallels or Fusion to be able to present a VM that can also host ArcGIS Pro and any other Intel-based applications. So the big question is right now, what about the M1? This is Apple and their new Apple Silicon CPU that is really based on the ARM infrastructure or infrastructural style. Currently, this is not a solution that has been tested and is viable for use of putting a VM on there and then running ArcGIS Pro. It just hasn't been vetted, but it's also new. And the information that's out there so far with the emulators that are being produced, Parallels will probably be the first one out the gate with something that works, but it's more the fact that you have to have now a Windows ARM system, so Windows 10 ARM, and that's in beta. And until these other areas are figured out, there really isn't a true viable solution. There will be beta options and things that will be tested, but not necessarily supported options that will be out there until the rest of that industry cooks itself fully and has a real solution in place. So Esri will be waiting on that to happen. We're going to make sure that when this is released, or if we release anything that says that this is a supported methodology, that it's been tested, but it's also vetted by the industry, not just Esri. We want to make sure that it's a solid solution for everything. So M1 with a VM and ArcGIS Pro right now, that's not happening as of this time. There is some chatter online, people that have done with the beta testing, and some things do work. And we do have a few folks that are offline testing with M1s of their own, but that's not official Esri testing. And that's even from a couple of us on the Esri team that have M1s that are our own personal devices. So we will be playing with this and looking in the future, but it's still not a published solution yet to be able to have Parallels or Fusion that's going to support ArcGIS Pro on an M1. So what do you do then? So this is where ArcGIS Online comes into place, or the hosted virtualization options. The hosted virtualization options are probably your easiest because you can just connect to a cloud instance and move from there. But also, this is where the SaaS components come in, that you can use ArcGIS Online for a lot of these functions. You're not going to be without options. There's always going to be something there. I've given you some bad news. It's really just delayed news. Doesn't mean there won't be a solution. It's just right now, we don't have the full one for the M1, but over time that may change. But there's always an option. And that's where virtualization does its best piece, because you can suddenly have more capacity there.
Ryan, just for sake of time, let's go ahead and keep going and talk about PAD very, very briefly. And I want to make sure that Miriam and Peter have an opportunity to discuss.
And so this is my last slide, is about a performance assessment tool that we recently released. The ArcGIS Pro Performance Assessment Tool is a suite of tools that has been released. And this is something that you'll see some information online more and more to support 2.8. The big push on this product and what it does is to be able to test your systems. So if you're using a virtual machine or a desktop machine, you can see if it's performing properly. And it is new, but it is free, and it does give you a lot of good, solid information that give comparables that can help understand if your system is performant. So with that, I will turn it back over to you, Jerry.
Wonderful. Thank you so much, Ryan. And Miriam, would you like to start sharing and join us?
Yeah, sure. So I'll introduce myself while I try to share. I'm Miriam Olivares. I'm the GIS librarian at Yale University. I work at the libraries, and we are the hub for all GIS support services on campus, across campus. But also I happen to be the admin for Esri software, if you know what that means, including collaborating with IT, library IT, and all the users to make sure that the infrastructure that we have is aligned with what they need. So today I'm gonna time myself, just so sorry about that. So today I'm gonna tell you the story. As Jerry mentioned, we had a virtualization story to tell, but I'm gonna tell you what was happening before and then after. So maybe you can get some points to bring back to decision makers, or if you are the one who can make the decision, I would encourage you to do so as soon as possible. So at Yale, we have branding for the virtualization, which is called My Apps. And it's Azure Virtual Desktop, but My Apps have a story before Azure that I'm gonna tell you. So let me just go to the next one. Okay, so just to give you some background, Yale is kind of a mid or a small size university, but we have around between 750, 800 subscribers all the time for the mailing list that we manage. We have also a high level of Mac users and the student population. Undergrads are around 85%, where grad students are 75%. So just imagine us dealing with that on a daily basis when they want to access desktop and then they have a Mac. So one thing that I want to make sure that everybody keeps in mind is, yes, we have a lot of beginners who can use SaaS. ArcGIS Online, in this case, is the most used platform for the web-based suite. But if you want to publish a map, as you know, this platform does not allow to manipulate to prepare the publisher sound images of maps. So I normally ask the ArcGIS Online users to move directly to desktop to open their maps, create the images. So there's always some need for desktop, even if they are web-based users. So for staff, is the contrary. We have a low level of Macs versus PCs. I believe it's part of budgetary decision making. So we also have a high performance computing facility, which is Linux based. And here is where I'm gonna start talking about my apps. Before the pandemic, we have a Citrix-based My Apps, and it was installed in few public labs, very few public labs, and all residential colleges where undergraduate students live, and only available for graduate students and professional schools. So also, I learned as a service provider that these apps were available only without making it aware to the entire population. So I was giving a secret away, telling you can access it online, but I think I was doing the thing that was not supposed to do, but I was desperate at that point. So the Esri desktop implementation and deployment is done by several, the Yale University Library, the ITS Endpoint Engineering team, and the School of Environment that has a very GIS-centric help desk and back up the license server. We still use ArcMap for some fields, like for instance, archaeology, that will go to sites and they really don't want to be having the issue about connectivity. So before virtualization, there was a solution that the Yale School of Environment did, that they were selling USB drives with VMB Fusion that had troubleshooting service as part of that. And the ITS walk-in centers were just saying VirtualBox installation for students. However, there was a misconception thinking that the students know how to install those virtual machines, and they didn't have the knowledge even to navigate between the laptop and the VM. Also, we hear often that our colleagues think that because they are Yale students, they would have powerful computers. Actually, many students do not own a computer. So when COVID came, the public labs were out of the equation. And then we started having all these issues, how students will connect. So hopefully we had my computer is, yeah. So we have a top-down decision due to COVID, and it was a game changer. The My Apps was developed for everyone on campus. I think except staff, just because we have machines where we can install this software. So My Apps provide access to virtual desktops, which contain the Yale licensed software to students and faculty anywhere in the world. The service runs off virtual machines in Azure, which are directly connected to the Yale network. You don't need VPN to connect. The availability is guaranteed, as you can see in my slide, that says 99.9% of the time, at least for one instance. The environment is accessible for any Windows, Mac OS, iOS, or Android device, as long as you have a browser and you have Wi-Fi. Of course, it improves version control for usage, and also the ability to customize virtual desktops. So GIS Performance, what happened is we were using my apps as it was built, and we knew performance was not ideal. But then a class for a 3D assignment triggered an IT desk help in the Yale School of Environment, Scott Romach, my colleague, to reach out to ITS endpoint engineers, and they start discussing about adding GPU. So they decided to review and enhance the performance. And this is what happened that I highly recommend to do. And I have learned throughout the years that if you don't ask, you won't know. But I asked faculty members and the ITS endpoint engineering if they were willing to work together and start testing the machines, and both groups said yes. The engineering group said yes, we want to build a better machine, and the instructor said I'm gonna devote time until the machine is the way we need it for our students. So they worked closely, and it just went tremendously well. ITS endpoint engineers have reported that before they would just need to wait for complaints when they build something, and now they are receiving feedback immediately on real time. So my apps became now we have two options. When you open the My Apps instance, you have on the right-hand side the Yale My Apps, and on the left-hand side, ArcGIS. This is huge for us. Just think about it. The whole university is giving us this opportunity to have a powerful computer. After testing, they decided that they were going to deploy the GIS machines with GPU and NVIDIA Tesla M60 and V6, dual monitors that is ideal for mapping work. Right now, we have 150 unique users, plus all the users that can install the software on their PCs and their computers. And we have a total of 2,000 unique users for the My App. So a high number of machines are used for GIS. And you can see all the benefits, things that is environment uniformity, increases teaching efficiency. For instance, in the past, a faculty member will hear that a student says my geoprocess is not finishing, but was it because of the system, a student error, etc. So uniformity reduces the guesswork for faculty members, easily scalable to meet demands, and many other things. One thing that I want to highlight in my slide is public safety, because you have students that sometimes had to come back at 11 p.m. or 2 a.m. So now they can work from their homes or their residential colleges. And it is really a step ahead to level the playing field in learning, although Wi-Fi plays another factor for that. So I just want to share two feedback quotes that I got from instructors. And the first one says the remote virtual desktop has been absolutely terrific. It's been wonderful to have all the students ready to go on the first day of class in a reliable and predictable environment. I teach live from the remote virtual desktop, do all my own work there, and support students using it. It's been indispensable. So you know how supportive they are. The ITS team and point engineers, they couldn't attend because they are in different obligations, but two of the instructors who worked on this, I saw they are here, and they really don't need to learn about this at all. And the second slide, I'm gonna let you read, because it's a really nice feedback from Professor Tomlin, and is the way that I'm gonna finish. And at the end, I have emails for my colleagues from IT and point engineering, from the Yale School of Environment, Scott Romach, and myself.
Wonderful. Thanks, Miriam. Just fantastic story. So we'll let folks read that. Well, I guess for the sake of time, we'll move on. We're still out of time.
Screenshot.
There you go. Yes, take a screenshot, and you can finish reading later. So wonderful comment there from Dana. But yes, so for the sake of time, let's move forward with Peter, and then hopefully we'll still have a couple of minutes for questions.
Okay, yeah, so I'm going to talk about some of the non-SaaS ArcGIS here at U of M. and not necessarily all of it, but focus mainly on some solutions we did for Pro for coursework, where we compared AppStream and EC2 instances just over 3 semesters to see which one worked for us better. And if we have time, I'll talk a little about ArcGIS Enterprise, particularly using it with cloud-based virtualization. So cloud virtualization in general, as Ryan showed, there's 3 different vendors for it. And, we have business agreements with all 3 of them. And we found that when we've used them for ArcGIS, all are pretty much similar in cost and performance. So how do you decide? Well, I think which environment is someone already familiar with your institution is a good starting point. So you don't have to learn anything new, and maybe you already have systems to integrate with. And then also which vendor will give you a grant to cover costs. A lot of the education uses, like the class we're going to talk about here, you can pretty much have all your costs covered through AWS Educate or the equivalent programs with Microsoft and Google. At U of M, AWS is the first on our campus, so it's certainly still the most common. In terms of the hardware, as Brian mentioned before, the T4 GPO is really a good point for running Pro. Both EC2 and AppStream offer similar hardware under slightly different name. So the performance we're getting there is relatively comparable in terms of the underlying hardware. Some of the considerations for cloud visualization, I think, from the user perspective, it needs to be easy to access remotely. In the case of EC2, that means installing the Microsoft Remote Desktop Client. There's Windows and Mac versions. You can even get versions for Android and iOS if you want to do it on your phone or your tablet, but the screens are smaller there. Similarly with AppStream, you can access it through any modern web browser. So it makes it easy for your users to connect and run it. And then having a simple, familiar user experience when working with GIS. So in some cases, like in the case of EC2, we want to hide the complexity of the cloud. So we don't want to have students having to work with the cloud management interface. So as you can see down here on the left, we've hidden that all behind a big green start button. When they want to use an EC2 instance, they just go to a particular URL and hit that. And then a minute or 2 later, they can log in through Microsoft Remote Desktop and be off and running. Similarly with AppStream, you just point your web browser at it. After you connect, you got to wait a minute and a half or so, and then you're up and running. One of the key things in terms of Pro, and you've probably run into this if you tried to use it even on your own computer with a lot of these institutional storage systems that involve sync, like Google Drive or OneDrive or Dropbox, they just don't play well together. So even though some of these cloud solutions have these same integrations for Google Drive and OneDrive, you still want to avoid those as a storage location. It just doesn't work well with Pro and its continuous churn of files or large things. Single sign-on is another nice one. We have that across all 3 platforms, AWS, Google, and Azure, so that makes it really easy. Students can just use their login credentials that you're used to. So what is cloud virtualization like for teaching? I'm going to talk about one specific use case here, Earth 408. This is your typical introductory GIS course, 3 credits. Means you'd expect about 10 hours per week of student work on the computers. And we experimented with both AWS and AppStream. And I will say this wasn't very much a planned out experiment. Like a lot of things, the pandemic played a role here. Both the environments we're using, as I mentioned earlier, are quite comparable in terms of underlying hardware. We started doing this in winter 2020 when, like everyone else, we had to panic and get everything online. So we just have data from part of the semester. So it was just the last part we did virtually. We chose AppStream at that point, and it was about 7.5 hours a week that we saw students using it. So less than sort of the 10 expected. And the cost ended up being about $120 per student. But that was, a pretty atypical semester. If you can remember that far back when the pandemic was first hitting, there was changes in what the assignments were like, because some of them were dependent on things of being in the classroom and access to physical samples. And so it wasn't quite reflective of a typical semester. The following semester, in fall of 2020, we were fully virtual at that point, and we stuck with AppStream then just to see how it would behave under a whole semester's condition. What we found there is that students were spending about 12.5 hours a week on average working with it, and the cost came out to about $210. So doing some calculations, we decided we were going to try EC2 this past semester to see if that would bring costs down. And it did, even with students doing slightly more work per semester. Now, of course, as an aside, there's a bit of a red flag here. This is only a 3-credit class. It's a little unrealistic to be asking students to be doing this much work unless we're going to change it to a 4-credit class. So that's good feedback for the instructor to realize they need to think a bit about cutting back on the workload for the students. So AppStream versus EC2. Seth Perry, who many of you may have met from Virginia Tech, has also been evaluating AppStream, and he was going to speak today but couldn't make it. So I've sort of merged together some of the things we've found as we've both been experimenting with AppStream and EC2. We found that they're comparable in deployment and management workload as long as your university already has an existing EC2 infrastructure where you've integrated your Windows management systems. If not, then the advantage goes to AppStream. So if you're starting from scratch, there's a great PDF here from Esri with a link that will get you started up and running with AppStream quite quickly. The user experience is comparable. The time to first click in ArcGIS after you decide to want to use it, transferring data, using it with other applications. Both AppStream and EC2 we're using in desktop modes because you might click on a feature in ArcGIS Pro with a URL and you want to click on that and have it open in the browser. So you can't use AppStream in its traditional streaming sense. You need to use it in its desktop streaming sense. But again, EC2 depends on integration with your institutional system. So that nice, easy, big green start button that we have. If you don't have that, then again, the advantage goes to AppStream here. Comparable geographic and network coverage. AWS has data centers all over the world, so you can get close to your end users when you deploy this stuff. But both suffer that last mile of networking. If it's poor, then you may not be able to use these virtual. So for instance, students who can't get a good Zoom link from where they're at probably won't be able to use these cloud virtual solutions either. Continuing here, EC2 we found to be less expensive for this specific use case of teaching an intro GIS course. Both, however, costs involved come within the range of what's covered by AWS Educate grants. Not necessarily the generic education program, but you can make a direct request to AWS for your class to get it covered. AppStream in theory is less expensive. However, that depends on predictable usage. And one of the things we found with the students, and perhaps exacerbated by them being in different time zones, not being all here in Ann Arbor, but spread around the world, is it was really hard to predict their usage. So sometimes we had instances up and running that no one was using that we were paying for in the AppStream model. EC2 is more of a student, each has their own instance that they turn on and use and turn off when they're done. One showstopper for us with AppStream, though, that we ran into at Michigan, and this was specific to this course, is that there's a default 1 GB limit on persistent user profiles. And this issue arose late in the semester when students were doing advanced raster projects. So in other words, building up a lot of temp layers and things that were stored in the user profile, not necessarily in their geodatabase yet until they committed them. And ArcPro provides no control over keeping that temp data out of the profile. ArcGIS Desktop or ArcMap have the ArcTempter environment variable you could set. And there is an enhancement out there for Pro if you want to tag on to that and encourage Esri to fix this. But without the ability to keep that temporary stuff out, we did have students lose work as part of this. Only about half the students ran into this issue, and they tended to be the ones who had built up lots of temporary layers as they were working along. You can increase the user profile limit, but this potentially runs into other performance issues, and there's a link there to Amazon explaining this. But hopefully, if we can get that environment variable in there, then that'll take care of this problem for AppStream. Or if you're using it for situations, like a course like this, if you remind your users not to build up a lot of temp layers, or design your exercises that way, that can help as well. So just want to say a little bit too about virtual environments versus standardized environments. We don't just do this kind of virtualization for ArcGIS. We have on-premise virtualization environments provide access to students to hundreds of different applications, but that doesn't have the graphics hardware necessary to run Pro, which is part of the reason we went to the cloud. But we're also following a pattern, where we've done this for Adobe Creative Cloud applications and MATLAB and other things where we have specific things that people want to use. Now, one of the options with all these, including ArcGIS, is to do the bring your own device. And in these Intro to GIS course, even before the pandemic, we had the instructor spending about 10 to 20 hours per student helping a handful of them get spun up. So when the pandemic came along, they realized there was no way to scale that each personal environment is different. They're going to need individual help. IT groups on our campus, we don't support personal devices. We just don't have the bandwidth to do it. So not every student also has a personal device to do with this. So that's why we pursued the cloud virtualization route here. And that gives us a nice standard environment that's much easier to support at scale. So the more users, much better return on investment. ArcGIS Enterprise, I just wanted to say something about quickly here. In fact, I'll just check out this middle point here. We often have short-term needs with research projects for extra compute resources. And so we'll spin up a virtual environment in the cloud, and then you can continue to use the familiar tools like Pro that just now can take advantage of the feature analysis and raster analysis in the analysis toolbar on the portal rather than running locally on their computer. But just to give us a quick wrap up here and hopefully time for a question or two, I think the key takeaways are, as you approach virtualization, we'll just take a step back for a second and think, can I do this in SaaS? And if so, it's time to move on to ArcGIS Online. The other is to collaborate with your IT colleagues. Find people on your campus. If you're not familiar with cloud computing or virtualization, undoubtedly there's others on your campus who can help you out. And then pay attention to virtualization requirements and limitations, both for the cloud and the on-premise and the Mac. There's no point in pursuing some of these things when you just don't meet the initial set of requirements. And then the return on investment for supporting ArcGIS in a standardized environment, this could be on-premise or in the cloud, is generally much better than trying to support students running it on their own device, particularly at scale. But a lot of what's going to control what the right solution is for you is, what's your institutional landscape like? What already exists? Where does the expertise lie? On-premise, Azure, AWS? And then there's always the complexities of people, units, and budgets, which is really the challenge of not being able to provide a single answer for you today. It's going to depend a lot on your local circumstances. And I'll stop there and hopefully have time for a question or two.
Well, we're sort of out of time, but let's stop the share and let's ask all panelists to just join us on video, and maybe the facilitators will let us run a minute or two over time. Let's address one question, and then everyone goes around the room and addresses Peter first, then Miriam, then Ryan. You shared some of it, but what are your thoughts if you are to recommend a correct virtualization for MacBook users? So what does correct mean? What did correct mean for you? So any recommendations for correct virtualization for MacBook users?
Look at the system requirements page for ArcGIS Pro. That's your first step. If the CPU, the RAM, and the GPU have the capacities to run ArcGIS Pro as it is, just if you took it as a Windows machine or as a Mac, does that work? Does it check those boxes? If it does that, then virtualization on that is possible. If it does not, go to SaaS.
Okay, wonderful. Thank you, Ryan. And Peter and Miriam, what are your thoughts on the correct? What Ryan said?
Yeah, I would just add that the practice that Scott Romach had in the Yale School of Environment was really good. With the little USB drive, they removed a lot of troubleshooting. But yeah, the machine, if Ryan's suggestion is correct, then you can maybe have the little USBs. I saw that compared to the entire campus, and I would see the students in the Yale School of Environment having less problems than the rest of the students doing the other kind on their own.
Wonderful. Thank you. Thank you, Miriam. And thanks, Jennifer, for asking that question. So we got lots of questions. Some of them were typed. Thank you, Miriam, and folks that typed up answers. What occurs to me, it's probably best thing to do is follow up with a GeoNet blog, GeoNet, that is Esri community, the new Esri community, former GeoNet, with some of the Q&As that we could not address and just some of the kind of lessons learned from everything that the presenter shared. So probably the next logical step is exactly that. Do watch on the education blog. So I'm going to copy and paste a link there on the Esri community, former GeoNet. And the proceedings from this session are going to be available a few weeks out. So you can have a recap of that as well. But yeah, we'll find ways to continue this conversation going. And I know there's lots of interest in continuing that, and do keep the questions coming. So with that, let's go ahead and thanks again to Peter and to Miriam and to Ryan, and to all of the attendees for joining us for this session. We'll go ahead and conclude the meeting, and we'll see you in a future session.